So just tell me a little bit about your background
Yeah,
then.
absolutely. So I started off during graduate school. That's when I decided that I wanted to do more than just science. And so I started doing a lot more science communication, finding ways to do public speaking, to write, to do social media communication, stuff like that. And that kind of led me more towards where I am now, working in the nonprofit business. Now I do communications and marketing for a nonprofit, as well as doing research, as well as being a mentor and a director of a bunch of other programs.
How did you get into the space side of it? Where did that come along?
Gosh, that started very young. I was a huge fan of science fiction as a young child. I loved Star Trek. I watched like Star Trek: The Next Generation was my show. That was my era. It was the coming of age in that period of the
Oh,
late '80s, early '90s, discovering myself a bit more and finding out what I wanted to do with my life. And I knew it would be around science in some manner. I knew since I was 5 years old I wanted to be a scientist of some kind. But then getting to Star Trek and Star Wars and science fiction, horror, video and video games and things like that, it inspired me to want to know more about what aliens are and if they're even out there. And so that kind of circuitously led me on this long journey towards becoming an astrobiologist.
so just how does that tie together? The astrobiologist. How does that kind of
Yeah,
work?
so astrobiology it's not a single discipline of science. It's a huge field of exploring everything we know about what life is. If you go on a NASA website, it'll say that astrobiology is the scientific study of the origins, the evolution, the distribution, and the future of life. But as I always say on my show, Ask an Astrobiologist, astrobiology really is just the quest to understand life. It is a grand quest that we humans have been undertaking for millennia. It's the culmination of everything from our earliest written records of trying to figure out our place in the universe around us. And we're just now, just in this very short moment of time, starting to explore out into the cosmos and explore other worlds. And here today, the very first big image, the major image from the James Webb Space Telescope is going to be released. And tomorrow, there's another release of images. We're now looking deeper in time throughout the cosmos and through more wavelengths. And we're learning so much more about our place in the universe right now. Being an astrobiologist is pretty cool at this time, this point in history, because honestly, I think if there is alien life out there, I think we're pretty close to making some kind of detection. Maybe not definitive, but at least some kinds of indicators I think are coming very soon, especially from a lot of our work with exoplanets. I could see very soon having some indicators of possible signs of life out there.
I read an article. There are 20 amino acids have been identified on an asteroid. That's something that's fairly recent. We're identifying amino acids on asteroids that are flying
Yeah,
in.
so there's 20 amino acids that life as we know. There's 20 primary amino acids, but there's hundreds and hundreds of different kinds of amino acids. There's a whole big slew of possibilities out there. Life as we know it just settled on these very specific 20. But we've actually discovered amino acids in cometary material that we've brought back to Earth. We've discovered amino acids in asteroidal material that we've brought back to Earth, and in meteorites too. But right now we just had one sample return come back from Hayabusa 2, came back from the asteroid, and so now they're exploring these samples in Japan through JAXA, but also some NASA researchers and other academics across the world are getting access to these samples now and trying to understand them and seeing things like organics inside of them. And we have some more samples coming back right now from the OSIRIS-REx mission, coming back from another asteroid that will most likely also be very revealing and have a lot to teach us. And we can look at some meteorites too, meteorites like Allende and Murchison, and they have dozens of different amino acids that we've seen inside of these pieces of material. Just finding that kind of stuff, finding sugars and amino acids and nucleic acids out in space, like finding these things is telling us a lot more about the possible ways for the building blocks of life to come together to make life.
And is that in your view, is that the likely origin, or at least the recipe, or the ingredients for the recipe, that it actually is a coalition of things that came together from kind of space, and then they all settled, and then time had this wonderful effect on them, and we've evolved out of that?
I don't know. I don't think anyone does. And I don't think we'll ever know exactly how life started here on Earth. Unless there was like some super intelligent alien watching us from the outside and like taking a snapshot picture in time, and they can come to us one day and be like, oh, hey, by the way, here's how you were born. That'd be pretty cool. But because of the way that geology works, the most ancient rocks on Earth have mostly been destroyed and recycled through the Earth, through plate tectonics and through processing of our planet. There's only a few places on Earth that have rocks even anywhere close to the age of the planet. There are some places that have rocks that are like 4.2 billion years old, but those rocks have been very well processed and heated up and broken up and moved around through time. And so I don't think we'll ever know exactly how it started, but I think that there's a lot of really cool people doing research in the origins of life who are studying all these different ways that some of the building blocks can come together and some of the processes can happen. They're looking at things like exogenous delivery. Did asteroids and comets, did they bring some of the necessary organic material to the Earth? And then there's also endogenous formation of these things. And so endogenous is that these organics are being formed in place on the surface of the Earth. There are some people out there who think that life had to start around a hydrothermal vent on the ocean floor in one of these like black smokers or a white smoker, even a slightly colder hydrothermal vent on the ocean floor. But then there's also some other researchers out there. Bruce Damer and Dave Deamer not too long ago put out this hot spring hypothesis for the origin of life. They've argued that it's too dilute in the water around hydrothermal vents for life to start there. And so they've argued instead that life most likely required a dry surface environment, continental crust environment on the early Earth, but it was really the wetting and drying cycles around maybe a hot spring. So a hot spring would have energy, it would have a lot of chemical energy, basic raw minerals, raw materials and elements for life. And it would also, through these processes of drying and wetting, it will allow some of these different chemical processes to happen that could lead to an origin of life. I personally, what I think is going to happen personally, I would throw down money that in the very near future, and honestly with machine learning and AI coming up like it is right now to help us solve some problems like this, I would throw down money that within the next 10 to 15 years, someone's going to start using specifically machine learning and AI to help us figure out what processes and pathways could happen to make an origin of life. But I would guarantee that right after that, I bet that we're going to find 100 or 1,000 other ways to make an origin of life. I wouldn't be surprised if there's just a multitude of ways for life to start. And then after that, it comes down to Darwinian evolution, to processes of selection that then drive populations forward.
Yeah. What's the value of understanding what the origins of life were in terms of how it helps us move forward?
Yeah, we're looking for practical application. Along the pathway of trying to discover the origins of life, you have people who are spending their careers, or at least their graduate careers, learning about processes of how do we use machine learning to develop network analyses to figure out these different processes that come together. You have people who are learning things about wet chemistry and how to form micelles and other structures and things like that. And some of those people are going to go on and do work that is very relevant to medicine and to our own health or to material science and stuff like that. And so there's certainly a lot of practical knowledge built along the way that very much ties into like spin-off technologies and things like that. And certainly some of the technologies will allow for us just to do better work in general. Great ways of quickly analyzing a species of bacteria from some planetary analog environment in the Arctic or out in a desert. That technology would then, very shortly be used for medicine and for other technologies that we use. And so there's lots of ways to make those connections. But when it comes down to it, I still, for me personally, I just think of it more like the philosophical view of what this actually means for our species. We feel a biological imperative, not just to make more biology, not just to reproduce and keep our species thriving and make more life, but one thing that is very common of human culture over these past several millennia is this need to know what we are. Why are we here? Where do we come from? And so trying to answer those questions, it doesn't just apply to our immediate lives and the things that are going on around us. It applies to our ancestors who came before us and continuing their search for knowledge. And then in the long run, it applies to the future generations and what we can leave for them. And so we're thinking not just in the short term of how does this benefit me now, but also how does this benefit past and future generations of people?
Tell me, are you expecting to go up into space yourself at all?
I would love to. It's been a dream of mine since I was very young to travel into space. And so I had my ambitions of being an astronaut when I was young, and I think many of us do. I think so many young people across the planet are inspired by space. It's one of those things that connects a lot of us. I give talks to young children in many countries around the world, and one thing that always just gets them excited is and enthusiastic is just to talk about space and sending humans into space and learning more about our place, not just on Earth, but our place in space as well. but we still have had less than 700 people have gone into space over the whole course of
Yeah.
space exploration.
Fine.
And of those people, most of those people were very limited to a very specific subset of humanity. And so I think moving forward, we have a lot more people going into space, more perspectives. I, for one, would love to go into space. I would love to get my opportunity to go up on one of these either space tourism trips, or to have some reason to go do some science in space. If I had the opportunity to go to Mars and be one of the first Mars astrobiologists or Mars thinkers, or just to share human knowledge in a Mars settlement, I think I would go.
When you look at space exploration and where we could be in 100 years. 100 years, who knows what we'll have.
Yeah, absolutely. So it's like Bill Gates, right? Bill Gates, that most of us highly overestimate what's going to happen in the next 2 years, and then we almost certainly underestimate what's going to happen in the next 10 years. And honestly, we evolved to think in scales of space that are centimeters to a few meters. Most of us can envision a kilometer or two, but not super well. If I ask you, like, how exactly far is 1,000 kilometers, like, your brain doesn't really quite process that. And then you start talking about the scales of the universe. We're talking about light years, trillions upon trillions of kilometers. Things start to get way different. And then for scales of time as well, we've evolved to think of things. We can think of seconds, moments, and hours is not too hard. But even to ask me what I was doing exactly 7.5 days ago, I would have a hard time like pinning it down to the moment of exactly what I was doing. My mind doesn't function that way. And getting humans to start thinking over the course of years into the past or the future is very difficult. And I honestly, I think one reason that we have such a hard time getting people to understand the impact of space exploration, the impact of environmental damage and climate change, the impact of some of these larger existential threats and existential opportunities for us, is that we didn't evolve to think in terms of centuries and millennia. And if anything, I think we need better long-term thinking for the future and for the past to better frame where we are in the universe.
So, in terms of your world, what's the big new projects? What's the big new things that you're working on or working around at the moment that's got you
Yeah,
excited?
for research right now, I've been pivoting a bit. A lot of my current research has been focused on an Arctic analog for Mars and Europa, and how looking at the living stuff there, as well as the mineralogy from this place, can teach us more about what we're looking for in these other worlds and looking for life. But I've also been shifting a bit in my own thinking more towards meditation and consciousness studies, and how something like the overview effect. There's this idea coined by the author Frank White back in 1987 called the overview effect, where Frank had started off, he was thinking about this feeling you get when you're like in an airplane looking down, this feeling like you see the earth below, but it's very removed, and you start feeling a oneness almost. And he was interviewing astronauts, and almost all of them were reporting a lot of these same feelings, that by going into space and looking at the Earth from the outside, they were feeling more connected to all of humanity and the biosphere. They were feeling this connection to the Earth, and they were feeling the need to do something to make the future better, to make the world better. And that kind of idea of this overview effect that we have, it's something that you also find in meditation. When you're meditating, you can feel this connection to not just yourself and your presence, but also to other people, to the world around you. And so I think we need more mindful thinking in general from our society. I would love to see children being taught to meditate in schools and to be more present with themselves, to help them learn how to process their emotions and all the thoughts that are coming. I think in general, we do a pretty terrible job of helping our young people to realize that the struggle of living, it really is hard to face your existence. And now that we live in this period, we're connected more than ever before across the internet. We can speak to each other from across the planet in practically live time with just a fraction of a second of a delay, and it still feels like we're together in the same room almost. And so people are feeling more connected. There's so much information at their fingertips, and yet a lot of people are feeling more removed from each other and alone and separate. And I feel like somewhere in there's this exploration of our future as a species. And I think that really ties into astrobiology as well, and astrobiological thinking. When you start thinking about what other life might be like, and not only how do other biospheres survive and thrive, but what were other civilizations like? Are there other civilizations out there? And how did they survive some of these larger threats to themselves that we're now facing? We live on a planet where we now have the science and the knowledge and technology to understand that we are very rapidly changing our own climate on this planet. we are rapidly changing the environment of our planet around us. We are moving more Earth material now. And, our species is moving material around the Earth in mines and quarries and all these things. We're moving more material than many of the actual processes of the Earth itself are at the surface of the planet. And things are changing very quickly. And it makes me think a lot, about alien civilizations and how they manage to survive potential bottlenecks or potential threats to themselves. Sometimes in astrobiology, you hear this idea of the great filter. Is there a filter or several filters that are limits to a civilization actually being able to survive, or a biosphere being able to survive? And we might be facing one or more of those filters right now, and maybe too many people don't even realize it, that we actually need to work through this together. And so I've been thinking a lot more about these ideas of consciousness, of meditation, of human unity, and what it means for us to be a joint species pursuing space exploration, pursuing astrobiology together.
So if somebody wanted to delve into that a little bit deeper, either with you or some kind of studies that you've done, that you've looked at, where would you to get some more information on?
Yeah, it's still somewhat naive from my end. I haven't published yet. I'm still just collecting some ideas and writing a good bit. If someone was really interested in learning more, looking into Frank White and his work is a great place to start. Frank has several books that kind of touch in this vein, not just the overview effect, but he has some others as well, considering space exploration and its impact on humanity as a species. And then there's a lot of great researchers out there doing research in meditation and perception and consciousness and some of these ideas of what we perceive as a species. And again, I think that ties in really well to astrobiology as well and what some of us are studying. For instance, sometime back on my show, Sue Schneider joined me on the show. She currently directs the Center for the Mind at Florida Atlantic University. She's a researcher, a philosopher who studied the future of the human mind and the future of artificial intelligence and what's going to happen to us. I think that ties in as well right now, trying to figure out, where we are right now with the human mind and what the coming future holds for us as well.
And if you had one sort of message that you'd like to convey, either about previous work or your thinking for the future, specifically to the mid-20-year-old generation, what would that be?
Oh, yeah, it's a good question. I talk to a lot of young people of that age about careers in astrobiology, and a lot of young people are very interested in getting in astrobiology, and they always want to know, like, which university should I go to, which program should I take, which classes should I take? And it's almost always the same answer from me, that like those things do matter, but not as much. As what really matters is your own personal interest and being willing to put the time in, put the work in to really pursue your interests, finding the right mentors along the way who can help you. There's so many ways to get involved in space exploration right now in general. You don't just have to be an astronaut. You don't have to just work at NASA. I get that question a lot from young people from around the world who maybe don't have a space agency in their own nation, or don't feel a connection to people in their own nations who are also interested in these things. And they're like, how can I work for NASA? And there's a lot of great ways to eventually become a research scientist or an engineer and work for NASA. But you don't have to work for NASA to be involved in space exploration. There are many other space agencies, the European Space Agency, JAXA, there's a bunch out there. But there's also just a lot of universities, different research groups. Now there's a lot of nonprofits and even for-profit companies now that are coming up and doing really cool work in space exploration and satellite technology development and photographing the Earth and traveling to other worlds and sending people to space. I mean, there's so much available right now. I think we've only really just seen the very beginning of the space sector opening up. I think we're going to see in the very near future a lot more entrepreneurs coming on board who are very focused on how we can, make space exploration something that we can do, but we can also have a financial reason to do it and make some money out of it. And I think the young people who are interested are going to find out that there's going to be a lot of opportunities in the very near future for space exploration.
Thank you so much for taking some time to chat with me today. It's been absolutely fascinating. I'd love to keep in contact with you and maybe chat later on if that works for you.
Absolutely.
That's
Been a
brilliant.
pleasure.